Before we go back to the theory, let me show you the recursive merge at the example we have right here. Let's again say we want to merge our feature branch into the master branch, but now I add the following flag, --no -ff. What does this mean? This means I want to merge the two branches, but I don't want to use the fast forward merge. The fast forward merge, as I said, is the default one if you only have additional commits in your feature branch, which is the case in our situation here. So if we now use this no-ff option and merge our feature branch into the master, then you see that the merge was made by the recursive strategy. As I said, that's a non-fast forward merge. If we clear this again, and if we check our log, you see something interesting, right? We now have our complete history of the feature file here in our master branch. Remember, we are in the master branch, so we have our first commit in the master branch, we have the second commit, we have the first feature commit, we have the second feature commit, and we have this, merge commit. I didn't name this commit, right? This was automatically created by Git as I used this non-fast forward merging strategy, in this case, the recursive merge. And this actually shows you the difference between our fast forward merge and the recursive merge here. If we use the fast forward merge, this commit right here would not be, here, because the head of the master would simply be on our latest commit here, this F2 commit in the feature branch. But as we told Git to do this differently, we can now see that here both branches were merged. So you can also use this recursive merging strategy in cases where the fast forward merge also works. But we have different application areas for the recursive merge. Let's again look at our theory. You know that we have this situation in our project. We have the master with 2 commits, then we have the feature branch created after these 2 commits, and then we have created 2 commits in our feature branch. Now we saw that we can use a recursive merge also in this situation. This is what we just did. But typically the recursive merge occurs if you have changes in the feature branch and if you also have new commits in your master branch. So basically the base for the 2 branches is no longer the same. Initially, both branches were based on the M2 commit, but here the master now has the M3 commit, whereas the feature branch is based on the M2 commit in the end. So we have kind of a deviation here, and for this, the recursive merge strategy comes into play. What does this mean? Well, in the recursive merge, we have additional commits in both the feature and the master branch after the feature branch was created, which is happening right here, and an additional merge commit is then created in the master branch. That's what we just saw with this non-fast forward strategy that we applied. Let's now have a look at this in practice again though. For this, we'll first undo our merge. And now very important, you see in here that we have our head and we are in the master now, and that we could actually say that we have to go back 1, 2, 3 commits. But this is wrong. We only have to go back 1 commit because this latest commit was our merge commit. I can show you what I mean by this. If we reset in a hard way our head of the master branch and go back 4 commits, for example. Was it 4 or 3? It's 1, 2, 3. Sorry. If we do that, this is not working. We have the path which is not part of the working tree. So basically we cannot go back 3 steps in here because, in the end, it's only 1 step. We only have to undo this latest merge commit to bring back our head for the master to this M2 commit here, to this one, as this was our latest, master commit. So this means we can use our git reset hard command, but we only have to go back 1 commit, the merge commit. If we do that and log the information, you can see that the head of the master is again our M2 commit here. If we check out our feature branch, you see that if we log it, F2 is the head in here. So everything is basically the way it was before. Now let's switch. You see I changed switch and checkout as I prefer, to be honest, so you can use both commands here. So let's go back to the master. And now we have changes in our feature branch, but this time I want to add another file here in my master branch. So let's say this is the M3 text file, and let's drag this into the master folder. Yes, I want to move it. Now we'll add this change and commit it, of course, with M3. All right. And now I want to merge both. Now let's do this with our good old merge command. So we use git merge and now feature. Remember, we are in the master branch. And now if we confirm this, you see that by default, so I didn't add no FF or anything like this, by default the recursive merge was applied, as I said, due to the fact that we have changes in both our master and the feature branch. Now if I check my log, you see we have again a merge commit as we had it before. Then we have the commit in our master branch, so that's the change we made in this master branch. And if we go down, we have the changes made in our feature branch, and then we have our M2 commit down here, so the latest commit in the master branch, before the creation of the feature branch happened. You could, of course, also squash this merge once again if you want to. So let's again reset the head in the master hard here. So we go back one step. So we can again log this. As you can see, now M3 is our head. And if we now say, it's clear again, if we now say git merge dash squash, right here, the feature branch, let's do this. And let's now log it. Then you see we only have M2, M1, M2, and M3. So all the commits made in the master branch are there. But if we now check our status, you see that the commits of the feature branch are not there. So for this, we again have to commit these changes with a new commit message. So this is again master and feature merged like this. And if we log this again, you see we now have a clear flow of M1, M2, M3. So all changes made in the master branch. And finally, we have our merge commit where both branches are combined. So this is how merging works in a bit more detail when it comes to a fast forward merge, a recursive merge, and how the squash command helps you to better combine these different commits. Besides the merge command, we also have another command though, which we can use for such operations. That's git rebase. So time to explore this as a next step. So let's leave the world of merging and let's dive into this git rebase alternative, as I would call it right here. What is a rebase? Well, let's again think about the situation we have in our practical example. So we have this master feature structure, one additional commit in the master after the feature branch was created, two additional commits after the feature branch was created based on the master. Now, as we learned, we can use a recursive merge to kind of bring the changes from the feature branch into the master, or we can use the rebase concept to do, well, the following. We can add basically these commits we created in the feature branch to this updated master branch. So typically we started with the second commit of the master branch in the feature branch, but now we added it to the third commit we created in the master branch. This would actually result in a fast forward merge in the end. And with that, we would avoid an additional merge commit. Before we dive into the practical application of this logic, let's see what happened here. That's the status we have before we use this magical rebase. In the rebase, we are basically able to, well, kind of get rid of these two commits. We won't get rid of these, of course, but the idea is that we are able to make this latest commit in the master branch the new base commit for the commits created in the feature branch. So basically this third master commit is now here with that rebase command, meaning we rebase the master in the feature branch. So the changes in the feature branch are now based on that latest commit in the master branch, like this in the end. With that, we have a clear commit history, so to say. Well, then as a next step, we can simply use our merge, we learned about that previously, to merge this rebased feature branch into the master branch. This is what we saw on the last slide, and this is what we can do with that rebase. So is rebase then the best solution ever? Well, no. Because it's important to understand that the rebase does not move commits, it creates new commits. So F1 and F2 here will become new commits with new hashtags. The content of the commit is of course the same, but when you use this rebase command to kind of bring the third master commit ahead of the feature commits, then these two commits will get new hashes. Now, if you're working locally in your project, this is not a problem, but if you have commits outside of your repository, so in projects you're sharing with other people on GitHub, covered in the next module, then rebase is something you should be very careful about. On the official website, you can even find the sentence, never rebase commits outside your own repository. I'd say it depends on the project, so you can also align yourself with your colleagues and then try to rebase, but it's not what I would recommend for the beginner to do in public projects. Here in our local environment, we can of course test this. So with the theory out of the way, let's bring more light into this rebase concept and let's see what happened here in practice.